Display technologies are currently undergoing a revolution, and one of the many exciting challenges is how to produce three-dimensional displays. Well, here I have a step towards a three-dimensional display. It's actually a spherical display. And at the moment it's showing a globe. But what's special about this display is that it supports touch. In fact, it's a multi-touch display, so I can spin the globe around. And what have we got? This looks like the Middle East. There's Africa. So the Royal Institution is up here somewhere. But of course, unlike a regular globe, I can spin this around in different directions. So we can take a look at Antarctica. And it's surprising just how enormous Antarctica actually is. Now, something else we can do with this display is this. I have here a special type of camera. It actually has 5 separate little cameras here looking outwards through mirrors. And special software can stitch these images together to make a single continuous 360-degree panorama. Now, we have an identical camera to this, positioned just outside the lecture theatre, where we have 7 volunteers huddled around the camera. So we're going to bring that panoramic display up on this spherical surface here. And can you hear me out there? Could you all wave if you can hear me? All right, so let's see, what have we got here? There's a young lady in a blue top with a necklace. Can you wave? Can you wave? Yes, that's you. What's your name?
Alex.
Alex, all right, welcome Alex. Who else have we got? Let's go around a little bit further. Oh, there's another young lady with a blue shirt on and a necklace. Hello, yes, that's you, yes. What's your name?
Shay.
Jay, okay, welcome. Well, if you'd all like to come back into the lecture theatre now, please. So the sphere is good for displaying certain kinds of information, but if you want a truly three-dimensional display, it would allow us to look around objects as we move our head from side to side. So could we achieve that using a standard liquid crystal display? Well, to find out, I'd like a volunteer, please. Who'd like to come on down? Let's have, yes, would you like to come down? Stand here. What's your name?
Owen.
Owen. All right, Owen. What we've got here is a special hat for you to put on. So if you'd just like to stand still there, and I'll help you fit this on your head. Put that on your head. Can you do that strap up?
Yep.
Got it done? Okay,
yep.
Excellent. Now on this hat, we have the tracking bar from a Wii games console. So at each end is a special light that emits infrared. We've also positioned a camera on top of the hat. Now, the camera is nothing to do with the demonstration. It's just so that we can see what Owen is seeing from his point of view. Right, if you'd like to turn around, what we have here is a standard liquid crystal display, but underneath we've mounted a camera that can detect infrared. In fact, this is just the remote control from a Wii games console. We've sort of swapped the remote and the tracking bar over. Now, I'm going to switch on the tracking bar, and if you'd like to just move your head from side to side, like that, and just keep looking at the screen, but just move your body. That's it. Try bending your knees slightly and dipping down. Good. And move just toward... Can you see that three-dimensional effect? It looks like you're looking inside a sort of three-dimensional room. You see that effect there? Okay. Excellent. Okay, thank you very much. So this achieves a three-dimensional effect by using a standard display. But of course, it requires the user to wear this special hat. And also, only one person at a time can see the three-dimensional effect. What I'm going to show you now is a new kind of display that achieves something very close to a truly three-dimensional image. And this is the only display of its kind in Europe. And I have the display over here. And what this is showing is a video taken from a medical scanner. And it's all sort of transparent. If you can see in through this with a close-up camera, you can see the blue at the back there is the spinal column, and either side, the yellow are the lungs, and at the base of the lungs, you can see it moving up and down. That's the diaphragm moving up and down as this person is breathing. Now, what's really special about this display, if we can get the camera in to have a look at this, is that if we just walk around this display and look at it from different points of view, you can see that it's actually three-dimensional. So three-dimensional, transparent movie suspended in mid-air. Okay, so how does this work? Well, to see how it works, I'm going to just switch off the display, and we'll just wait a moment while it slows down. So inside the cabinet here, we have a projector, and the projector sends images up and bounces them off a mirror, and they're projected onto this screen, which we can see slowly rotating as it comes to a halt. That projector is sending 6,000 images a second onto this screen. And each of those images is timed very carefully according to the orientation of the screen. So it's throwing out a different image in each direction, which means that as you walk round the display, you get this impression of a three-dimensional object sitting in midair. So we've seen some amazing examples of display technologies, but remember we said earlier that the goal is to make computers so easy to use that you don't even think about it. Well, in fact, we're often already using computers without even realizing it. For example, computers are now built into toys, and each of these lovely little robots has a fully fledged programmable computer inside. And on a good day, they all dance at the same time. They're doing pretty well, actually. Now here's another example of a computer. This is a credit card, and behind these gold contacts is a tiny microprocessor chip embedded into the plastic. I have some examples of these chips here. Each of these is one of the processors from a credit card. You can see the tiny gold contacts, and if I turn it over, underneath you can see the individual chips. Now, these may not look like much, but at the end of the 1960s, the Apollo astronauts went to the moon, and they used a special computer to guide them to the moon and to make the landing. Well, each of these tiny processors has 30 times the processing power and 100 times the memory of the Apollo guidance computer. Even tinier devices can also be made, and I have a demonstration here for which I'd like a volunteer, please. Shall we have, oh my goodness, everybody wants to volunteer. Shall we have you? Would you like to come on down? Yes, in the blue top. Thank you very much. And what's your name? Anna. Anna. Okay. Well, imagine that you're going to do a little bit of shopping here. So we've got some things in a shop that you might wish to buy. What I'm going to do is give you a shopping basket. I'd like you to just pick out 4 or 5 things that take your fancy, anything that interests you there. So we've got a few biscuits and a packet of sweets, water bottle, maybe 1 or 2 other things. What's that? Looks like an apron. Anything else? Pair of socks? Okay, that's excellent. So if you'd like to hang on there for a minute. Now, over here at the checkout, we have a scanner, and the scanner is connected to this computer. So if you'd like to bring the basket over and just place it on the scanner, that's excellent. And those objects that you've just selected appear on the screen here. So there's the bottle, the biscuits, and there's the socks, and so on. Now, how does this work? For the purposes of this demonstration, we've added to each of these items a tiny silicon chip. You may be able to see it here. This is actually the antenna, and the processor is in the middle. This is called a radio frequency identification tag, or an RFID tag. And the scanner detects the presence of this tag, and the tag sends a little signal to the computer with a unique number on it. And the computer looks up that number in the database, and it knows what object that corresponds to. And if we just click on one of these, let's click on that box of biscuits, and it brings up information. It tells us the country it was made in. This is made in Scotland, and the date of manufacture, and the best before date, and so on. Now, the interesting thing about these tags is that unlike a barcode, they give a unique identity to this specific packet of biscuits. So this allows objects to be tracked from the factory in which they're made to the shop in which they're sold. An intelligent fridge could detect whether something is out of date, and when we throw the packaging away, an intelligent recycling plant could work out what material it's made from and how best to recycle it. But just how small could we go? Well, I'm going to show you something now that's very new and I think quite extraordinary. Thanks, Anna. So in this little tube, I have some powder, and if I just turn it, it should just be catching the light there. In this tube are 10,000 tiny silicon chips, each of which is a 20th of a millimetre across and cost around a penny to produce. These are radio frequency identification tags, and each one has its own unique number. Now, there are about 300 trillion different possible numbers. And that's enough for us to label every single object that's ever produced, from a bicycle to a simple sheet of paper. Now, that truly would be chips with everything. Now, these devices just transmit their identity. But imagine a world in which fully fledged computers are as tiny and as cheap as these, in which they can sense their environment, in which they can communicate with each other, as well as with computers on the internet, combining information and making decisions on our behalf automatically. Well, such a world is not far away. Now, all this, of course, is made possible by the extraordinary technology of the microprocessor. But there's something else that's crucial as well. 50 years ago, each piece of information technology came in its own separate package with its own hardware. But today, all of these tasks are combined into a single piece of hardware. And it's an extraordinary thing called software that allows a single device to be turned into a camera or a dictionary or a telephone or a game. We'll be looking at the amazing world of software in tomorrow's lecture. Thank you.